Alright guys, welcome back to my YouTube channel and designing RF circuits, and this one is basically the same thing as what I've been doing with all my other videos, designing low noise amplifiers. It's basically the same thing. It's just that I haven't been able to have access to, like, you know, advanced design system software, and so I was thinking, like, well, why don't I just try to find a way to be able to design my own circuits without having to pay so much for, like, the cost of software and stuff. So, or like, for example, MATLAB, you actually, if you don't go to school or you don't have any work that has anything to do with it, then, you know, you have to figure out something for yourself, I guess. So, and if you guys like it enough, hey, if you could hit me up, maybe I can help you get a copy of this, and maybe, you know, give me some tips or something to give me in order to use this software. So so here we go. I am going to go ahead and start. I mean, this is basically just the basics. It's just that, you know, I started designing low noise amplifiers at first, and then in my other videos, and haven't been able to get back into, you know, the programming or the design of low noise amplifiers on my other softwares. So here's just a way in order to make a way that's fit for me and maybe fit for someone else that might like it. But I want to show you how I design my software, and I can actually design, like, for example, I'm going to create a 4 gigahertz low noise amplifier, and here we go. You can see there's a lot of code that I've done, up to over 4,000 lines of code or so, and there's a lot of stuff. So, but here we go. Start this, and so we need to first, as what I've been doing in my first videos, I've always been trying to stabilize the transistor using I'm going to be using S2P file for it. It's a little bit an easier way of doing this. I haven't, later on I'm hoping that I can actually design a full circuit design of, like, you know, an actual transistor and so, but just for now, what I have now is what I can get here. So I show you. So here I have a 50 ohm termination here, and so this circuit, basically, I'm going to have to go from left to right. I'm going to have to actually do the circuit within a specific way, because that's how matrices are multiplied with each other. So in order to get a result, then you'll see here. So first I'm going to probably do about, like, let's see here, 100 ohms here. So here comes next the S2P file, and S2P file here, I got a 3 volts 30 milliamps. I've been using the ATF5543 for a while, but you know, it's just something to use for now. So Maybe I can use another transistor later for another video, but basically I want to, create the software in order so that, I can actually design, create a software that can, do complex circuits, but whatever I can do now is I can show you here. So what I'm basically doing is just stabilizing the transistor with these resistors, 100 ohm and the input and 200 ohm at the output, 50 ohms here, and now I can go to stability factor, and you can see everything's above 1 for all frequencies. I can go down and up, but these buttons are actually intertwined with the other windows, so I might have to, change the program in order so that it can go back to its own initial position, but for now I don't want to go up and down with that right now, because that will intertwine with my other windows. For example, like this one. This is the Smith chart, so I'm going to start with, so right now, it does that sometimes. I have to go too far. So that 8 actually means, so I'm going to make a 4 gigahertz low noise amplifier, for example, or a preamplifier. It doesn't matter if it's, it's low noise or not. It's just I want to show you, how I can actually design a circuit of like a preamplifier with this software. So here you got 0. This is actually the first point. So I wouldn't be using like the actual gigahertz here. It's actually coming straight from the file here. But here's 0.1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, that would be 8, I think. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so it's actually at 0.8 for 4 gigahertz. And that sets my stability circles. These are stability, my load and my source stability. Now I can create a gain for that available gain circle for it. So I can start at 13 dB, for example. It's a huge circle, but I can go down. Let's see here, make it bigger, make a larger signal. That's still kind of enough. I can make something more there. 15.5, for example. Okay, that goes all the way to the end there. Let's see here. Let's go back to 15.5. Or 15, I mean. Let's do 15.2 or 1, for example. Now you can put in the noise figure parameters here. So at 4 gigahertz, it's about close to 4 is 3.9, so I'm going to use this. So 0.72 for minimum noise figure. Okay, I'll make this minimum noise figure is 0.72 as shown, and then the optimum noise, optimum reflection coefficient for the noise is 0.17 at 132.6. 136, and let's see, 0.06, 0.06, and I'm going to use a noise figure of about 1 dB. All right, well, that's pretty close. It's not like I actually did this before. It actually literally came out to be very close to this point. So I'm going to put a point right here between the noise figure circle and the available gain. I want more gain, and I mean a little bit more noise, so it's going to be, it's not like I'm trying to, it's a trade-off of how you would design your amplifier. So I can literally click on this point here, and it'll give my input and output impedances. There you go. That's I basically set my source reflection coefficient there, and it created my input and output impedances automatically. Now I can go to an impedance matching network website that I use. I think I used this before from my other websites. It's very nice to have this. Later on, I'm going to implement my program so that I can actually create my own design I could create my own impedance matching utility in order so that I can set those input and output impedances to the Smith chart and match it to 50 ohm input and output impedances. So, but that would be later on. This is just I kind of want to show you what I've been doing, and show everyone my software here. So, but yeah, I'll be doing that later. But for now, I'm using this utility online instead. So. Let's see here. So input impedance is going to be 15.2, 0.35, 15.2. So the source is 50 ohms, and then 15.2. The reactance is 0.35. And I'm working at 4 gigahertz. So I want a desired Q of something really high. I want my circuit to resonate only at that frequency. So I'm going to go as high as I can. So 1,000, for example. That gives me a higher, so I can just have that 4 gigahertz working. So here I have a high pass and a low pass, and then that would be the input impedance. Now for my output, using 26.8. Let's see here. 26.8. Negative 32.3. 32.3. Out of 50 ohms, 4 gigahertz, and desired Q of 1,000. Okay. All right. Here we go. So, in order for me to create a new circuit, I'm going to have to exit this program and reopen a new program again. So I used 100 and 200 ohms, I believe. Might want to write that down. What you use for your stability resistors, so you don't forget. So, all right. I'm gonna have to redo this one more time. Okay. Do this again. Alright, so 50 ohms here. Now, my input, I'm going to be using, so you want to use a high pass first. So it would be 1.3 nanohenries. Let's see here. 1.3 nanohenries. Nanohenries. Capacitor is 1.7 picofarads. Oops. And now resistor, 200 ohms. Or did I use 100? I forgot. I think it was 100. Okay. If not, then, you know, you might see some differences in the actual response of the system, but it may not be a big difference of the frequency response for 4 gigahertz. So, okay, this was 200 ohms, and now we want our output, and we're going to use a low pass, so it'll be 2.27 nanohenries. 27. And then 0.74. Oops. 74 picofarads. And then my output termination at 50 ohms. Okay. Now we can simulate the S parameter by clicking that. Invert it there. And that is my response at 4 gigahertz. So this would be my S21 line. These either are my S11 or and my, I think this would be a S22, and then this is the S11, and then this S12 at the bottom here. But yeah, that's basically what I've been doing now. But anyway, I hope you like my video and please subscribe. Thanks.